Hey, all of you. Today I am here with one video regarding the freshwater hydrophore system. This is especially for the phase 2 guys who are going to appear for engineering knowledge paper. This question is coming in MMD. The question may be like this, that draw a neat sketch of freshwater hydrophore system and explain the working principle of it and why it is required. What is the main purpose or objective of hydrophore system? So I'm going to show you that what is the hydrophore system and what is the utility part of it. So first of all, if this hydrophore system, basically it maintains the pressure for the water which is supplied to the accommodation area. You can imagine the situation where the water is required to bridge deck also, water is required to master's cabin, chief engineer's cabin, and down below also second engineer, chief officer, and third officer and third engineer, and also everywhere. Imagine a situation everywhere in the like evening after 5 o'clock, lots of people off from the duty and go for the shower. So at that time, everybody opens the tap. So if this is the requirement, then it is very difficult to supply the water to all the places with uniform pressure. And if the hydrophore is not there, this is not possible. And this is something which is your peak demand time. And in peak demand time, this is the part. Okay. So this is possible only due to the hydrophore, because this hydrophore, this maintains the positive pressure in this open area and it pressurizes the water, and due to this pressure the water get supplied to the accommodation area on different deck levels. There will not be any stopping of that, or maybe sometimes the water is coming or sometimes the water is not coming, so you will not have this type of trouble. So how this system works, we will see about it. Like we can see over here, we have two tanks. You can say that this is freshwater tank port, freshwater tank starboard. So we have this filling line. Filling line, basically it is coming from the freshwater generator. So after the water generation, the freshwater distillate pump supplies the water, and this water, you can see, we want to fill up this tank 2 or we want to fill up the tank 1, we will open the desired valve and the tank will be filled up. So this is something which is there. You can see this is something which is your vent of the tank. In both the tanks, this is the vent. It is required when you are filling up, the air will come out of this. And this is something which is your suction point. That's why it is from the bottom. The suction is from the bottom part of it. So here, if you want to use tank 1, we will open this valve. And if you want to use tank 2, we will open this valve. Okay. So let's suppose now we are opening the tank 2 part. So we are starting the consumption from tank 2. So tank 1, we will keep it close. Okay. So tank 1, this valve is open. These two valves basically is for the filter. This is your suction filter. And this suction filter, you can imagine, is something which is required. Because if any dirt, mud or something, it will filter out. So it will not go to the pump. So these two valves are there. If suppose we have to do the maintenance, then we can isolate this filter by closing these two valves and do the maintenance of the filter, that is cleaning, or suppose if the air is being sucked, then the gasket renewal or something, we can do it. Okay. So for that, now for pumping operation, this valve also has to be open and this valve also has to be open. Here we have the freshwater pump, freshwater hydrophore pump. Generally on board ship, you will have two sets. freshwater hydrophore pump 1 and freshwater hydrophore pump 2. Okay, and this set is in the parallel, same like that. So we can use one, and suppose if there is malfunction or something, then you can use two. Or normally we are going to change over also in every week or sometimes 15 days. So sometimes monthly basis also. So tank 1, tank 2, pump 2, like that, or vice versa. So now this valve also, this is the discharge valve of pump. It will be open, and it is something which is going to fill up the hydrophore. We have to keep this valve also open. This is something which is the drain of the hydrophore when completely depressurized and the internal cleaning is being required. So water has to be drained. We will open this valve, the water will be drained out. Here we can see this is your gauge glass, and we can see the water level outside. Okay. So in this one we have marking maximum and minimum. So this is completely automatic system. Here this maximum and minimum, I will tell you, it is attached with a pressure switch, and the pump operation is completely automatic. Pressure switch, this valve is there and this pressure switch is there. So let's suppose we set it the starting point of the pump. At what pressure the pump will start? So it is something which is, let's say, 4.5 bar. And at 4.5 bar, water will come to this level. And once the pump starts, it has to stop also for automatic filling it hydrophore. So pump stopping will be 6.5. So this pressure is being sensed by this pressure switch, and pressure switch will give signal to the freshwater pump. So what happens? Once the pressure reaches to 4.5, the pump will get signal, that is your start. And the pump will start. After starting, the water start filling up. And once the water start filling up, the level will go up. And once the level will go up, the air which is inside, it is going to be compressed, and the pressure will rise. And slowly, when it rises and it reaches to 6.5, the water level also reaches to maximum part of it, and the pump will stop. So that's how the automatic operation. After that, consumption will be there, so water level will come down, the pressure will drop also. And once the pressure comes to 4.5, again the signal will go and the pump will start and fill up the water into the hydrophore. So that's how the operation continues throughout the day. But in the engine room watch keeping, we have to see the pressure also. We have to see the level also. Suppose sometimes the pressure goes down or the leakage in the system, then we have to charge the air also. This is for the compressed air charging, and we charge the air in such a way so that operational range and the water level both maintained. That is your 4.5 bar to 6.5 bar and the operational level change. This is something which is there. Here we have this is your safety valve or relief valve. It is going to lift up if abnormal rise in the pressure or the level. So it will lift up and release it. And this is for charge. So this is something which is required once this valve is open and this valve is open, and in the various decks, starting from the you can say mess room to A deck, B deck, C deck, D deck, and also so this is something which is there, and it is going to continue, and everywhere the water supply is there. It is also going to supply to the engine room service also. Engine room service also going to be supplied. So this is something which is required and a very useful utility, hydrophore. And if this is not working, then we have the problem, and the water supply is totally interrupted in accommodation area. So we have to maintain this one. It's a very simple and very good utility for the ship part, and we have to understand how the water supplies in the accommodation area. So I hope all of you have understood the working principle of it, how it works, and the requirement, why it is there. So when you are going to write the answer, first you have to draw this sketch, and then you have to write down the main parts. What are the main parts? We have the tank 1, tank 2, or freshwater tank, port freshwater tank, starboard, and then the filling valves of this, the vent, On the sketch only you must mark. In this one it is not marked, but you must mark it. Okay. And this is your filter. It is not marked, suction filter. This is also the inlet side valve, inlet side to the pump and outlet of the pump. This is your freshwater hydrophore pump. Okay. And this is inlet to the hydrophore, outlet to the hydrophore, and going to the accommodation part, accommodation, and then this is going to be supplied into the cabin or the bridge, whatever the required. Okay. And here it is important part is your pressure switch. This is your charging air line. This is your relief valve. This is your gauge glass, and this is your complete hydrophore vessel. Okay, and this is the drain line. So in the diagram only you can mark it, and then in that after you can explain the working principle of it. And finally, if you have any conclusion, then also in the last you can write. So this is the pattern you must follow and explain the answers of it. So I hope whatever I have described today, it is going to clear your doubts and you can answer the MMD question successfully. Thank you all of you. Keep watching.